Okay, today we're going to be talking about using different methods to graph. Now this is a review, but if you haven't used MyMathLab a lot, then it's really not such a review. Well, all right, I'll just do that. Okay, all right, so the first thing we're dealing with today in 2.6 is graphing linear functions. We can all graph, presumably, but on MyMathLab it can be a whole different trip. And we're also using specific methods, and if you don't use this method, MyMathLab will grade it wrong. And MyMathLab can tell by the points that you choose to graph. So let's use the methods we're being asked to use. This first group of problems asks you to graph linear functions with by using intercepts. So we get to review how to find intercepts as well. Okay, so I am make this a bit bigger, maybe that'll be okay. What I see here is 3x plus 4y equals 12, so I'm going to write that larger here if I click on the black pen. 3x plus 4y equals 12. This is a linear function in standard form. So I'm going to say linfunc in standard form. Now, why does that matter? Well, it just so happens that it's much easier to find intercepts when you've got a line in standard form. This is why. If I let x equal 0, that's going to give me the y-intercept. Okay, so if I want the y-intercept, y-int, I have to let x equal 0. So I'm going to let x equal 0. That'll be 3 times 0 plus 4y equals 12. Well, 3 times 0 is 0. So 4y equals 12. Divide both sides by 4 so that I get y by itself. And I find out that when x is 0, y is 3. So my y-intercept is going to be the point 0, 3. And now to find the x-intercept, I let y equal 0. So I start out with 3x plus 4y equals 12. But I'm going to let y equal 0 this time, so I'll have 3x plus 4 times 0. Equals 12. So 3x equals 12. Divide by 3. Divide by 3. X equals 4. So when y is 0, x is 4. So that means that my x-intercept is the point 4, 0. Those are the only 2 points that you're allowed to graph if you want to get full credit for this problem. So now that I have my y-intercept and my x-intercept, I'm going to pull this over so I can still see it. And I'm going to click to enlarge the graph. I'm graphing a straight line. And it's up here. Up here on that yellow banner, it tells you what to do. Click the graph to plot the first point on your line. Well, I might as well make it 0, 3, since that's the first point I found. So 0, 3. And notice that up here in the right-hand corner, this tells me what point I'm on. So 1, 2, 3, here we go. Click. Now, it says click the graph to plot your second point, the second point on your line. And that's going to be 4, 0. So there's my line. All I need is 2 points. And I am going to come down here to save. And save my line and then check my answer. And it says excellent. So we'll go to the next problem. Now this is a bit of a tricky problem. This up here was problem number 1. Now I'm going to come down. Oh, I'm going to save it. All right, wherever it's going. I guess I better put it in the right place, huh? Live streaming, that's your name to me. The live streaming class. Okay. All right. Now, here we are. We're going to do number 2. Sounds like we're going to the restroom. Number 2. This time we have something that looks really weird. Let's pull this over for a minute. F of x equals -5 minus 5x. Now stop and consider. This is something of a trick problem. You're not used to working with f of x, but that's just y. So you can rewrite this as y equals -5 minus 5x. And now we do exactly what we did before. To find the x-intercept, I let y equal 0. To find the y-intercept, I let x equal 0. So if to find the x-intercept, I'm going to let y equal 0. What did I do first? I want to do the same steps over and over. The first thing I did was let y equal 0. That'll give me the x-intercept. Okay, so if I'm going to let y equal 0, that will be 0 equals -5 minus 5x. And now I have to solve this equation for x. So it looks to me like the easiest thing would be to add 5 to both sides of the equation, because -5 plus 5 over here equals 0. So I will have 5 equals 0 minus 5x, and 0 minus 5x is -5x. So 5 equals -5x. I divide both sides by -5 and -5. The -5's cancel. Whoop, whoop. Okay, so I will get x equals -1. So now I know that when y is 0, x is 1. And that gives me my x-intercept. Now, come down a little lower. And I'm going to let x equal 0. and that will give me the y-intercept. So here's my original equation. This is easier. All I have to do is put a 0 in for x, and I'll find out what y is. Of course, -5 times 0 is 0, so that will give me y equals -5. You could say -5 minus 0 or plus 0, but -5 plus or minus 0 is just -5. So y equals -5. And now I know that when x is 0, y is -5. And now I will plot my points and get a line and hopefully get all my percents. Okay, so click. I'm graphing a straight line. Okay, so how do I know I'm graphing a straight line? Because up here, the x is to the 1 power, and the y is to the 1 power. And down here, the y is to the 1 power, the x is to the 1 power. Whenever all of your variables are to the 1 power, you have a straight line. That way you always know when to graph a straight line. But look what I did. Okay, clear, yes. Now let's try this again. Straight line. I am going to choose 0, -5. Which is right here. And then, come on, 1, 0. So I'll come to 1, 0. And then I'll save, and I'll check my answer. Ah! All right, -1. You see what a little negative sign will do? That should have been -1. No wonder, now I have to start over. Is it going to let me start over? I think so. So I'm going to clear. Yes. Now let's do this again and be good. Okay. I hit my straight line. I go to 0, -5. And then I go to -1, 0. Doggone it. And look in the upper right-hand corner. That says I'm at -1, 0, so we agree. Now I'll save. Now I'll check. Yes. Okay. One little nasty negative sign. Ugh. And here we have a problem that's not in any form. It's not in standard form and it's not in slope-intercept form. So I think I'll put it in slope-intercept form first. And I'll erase my paper after I marked it all up. There, and there, and there, and there, and there. To kind of try to keep it neat. Okay, this is, ow, bit my tongue. This is number 3. 3y equals -12 plus 4x. Now what I'm about to do isn't necessary, but I have this kind of OCD part of my personality. Most math teachers do, and when we see something that's in improper form, we kind of sort of go crazy. So this is going to be y equals -4 plus 4/3 x. And then if I really want to be in slope-intercept form, I would turn it around like this. Probably would have been easier just to leave it the other way. Anyway, look what I already know when I have a line in slope-intercept form. I automatically know what my y-intercept is. The y-intercept is 0, -4. So when I have a line in slope-intercept form, if you're lazy like I am, you can always just go ahead and find the x-intercept. The x-intercept is always harder to find. It can be a pain. Here we go. Here's the x-intercept. And it's what I get when I let y equal 0. Okay, so here's y. 0 equals 4/3 x minus 4. So I'll add 4 to both sides. -4 plus 4 is 0. That means I'm left with 4/3 x. Would definitely have been easier just to leave it the way it was and work with it that way. Oh well, you live and learn. Now, I am going to multiply both sides of this equation by that denominator. This is a wonderful trick. And you should consider doing this more often. Let me move this over a little bit. Okay, because when you multiply by the denominator, you cancel out the denominators, which means you get rid of your fractions. So I am going to multiply by 3 in the form of 3/1 right here. And that's a multiplication sign. And I'm going to multiply by 3 over here. Now that gives me 12. Up here, the whole reason I did this was to cancel out the 3's. The 3's, a 3 up there will cancel a 3 down here, and that's called cross-canceling. So I'm left with 4x, and I will proceed to divide by 4, so that what I get is the 4's canceling. I'll be left with x equals 3. So my x-intercept is going to be 3, 0. All right, so I've got a y-intercept 0, -4, and an x-intercept 3, 0. And now we'll go graph these. Usually you can graph a straight line using any 2 points that are on the line. But when the instructions ask you for intercepts, you have got to give intercepts, period, or it'll mark you wrong. And you don't want that. Now, it's kind of depressing. So, especially when you're the teacher. So, okay, here we go. Graphing a straight line. Click the graph to plot the first point on your line. Okay, 0, -4. And the point in the upper right-hand corner agrees with me. I just didn't want it to say something like 0, -4.1, because that would get me marked wrong, even though I had every intention of doing it correctly. Now the x-intercept is going to be 3, 0. And I save, and I check. Yay. Okay, we have graphed 3 linear functions, in other words, straight lines, with the intercepts. The x-intercept, this is the x-intercept, this is the y-intercept. Okay, now, let's move on to the next group. is biting me because I won't pay attention. She's a really rotten cat. Okay, now we're going to graph linear functions, straight lines, but we're going to use a method called slope-intercept, just like slope-intercept form. Only you're going to see there's a particular trick to it. I don't know if we've already talked about this before, but we're going to do it again. So this is problem number 4. And the equation we're given is y equals 6/5 x plus 7. Okay, now the slope is 6/5. And the y-intercept is 0.7. And here's the strategy of using the slope-intercept method. You start on the y-intercept. Okay, start on the y-intercept. Then use the slope as a roadmap to your next point. So that means we have to kind of analyze the slope and what it really means. So let me write this out. Then use slope as a roadmap. Okay, so how do I use 6/5 as a roadmap? Let's look at what 6/5 is. The slope is the rise over the run. Yes, 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 we've already been through that. But what does that mean? What that means is that the slope is a ratio of the vertical change or vertical movement, let's say that, vertical movement to the horizontal movement. And now I'm feeling insecure. I want to make sure I really did. Yes, I did. Okay. It is recording. Ever so often I worry. Okay, so you've only got 2 kinds of vertical movement. If we're talking about strictly vertical movement, you can only go up or down. You're limited to those 2 movements. So you can either go up or you can go down. That's it. Okay, so since 6 is positive, what that means is you're going to go up 6 units. Now I'm going to move this over for a minute. Suppose I had a -6. That would mean down 6 units. So the numerator of the slope tells you whether you're going to move up or down and how many units you're going to move. Kind of like north or south. Now the denominator is confined to only strictly horizontal movement, which means you can either go left or you can go right, and that's it. Almost knocked my water over. That's an arrow, believe it or not. Left or right. So since I have a +5, that's a +5 up there. That means I'm going to go right 5 units. Now, if 5 had been negative, that would mean go to the left 5 units. Well, as it is, whenever I have a positive slope, like 6/5, remember that negative over negative is positive, so this could be changed to -6 over -5. This would mean I could go up 6 units and to the right 5 units, but I would stay on the line if I went down 6 units and to the left 6 units. And now we're going to do this and you'll see what I'm moving about. Yeah, what I'm talking about. So here we go. I start on 7 on the y-axis. So let's click. Let's click. And I'm going to start on, let's see, this is 2, 4, 6, which makes halfway up there 7. And notice that the point in the upper right-hand corner on the yellow banner agrees with me. That helps me put points on the right places. Okay. Now there I go. Now I am going to follow the roadmap provided by the slope. I'm going to go up 6. So I have to count carefully. 1, 2, 3, 4, 5, 6. And no, don't click now or it'll be just a vertical line. We have to also go from here, we have to go to the right 5. 1, 2, 3, 4, 5. Which would put me at 513, so I want to make sure I'm not like wavering and like getting 5.1 or 13.7 or something like that. But no, it says 513, so I'm going to click there. And then I'm going to save. And then I'm going to check my answer. Nice work! Okay, but I'm not ready to move on to the next answer because I want to show you what would happen if I had gone the other way. If I had gone down 6 and to the left 5. So here I am at 7. Now suppose I go down 6. 1, 2, 3, 4, 5, 6. And then to the left 5. 1, 2, 3, 4, 5. I'm still on the line. So my math lab will only accept these points from you. You can't use any points on the line, but you can use these points. You can use 7 and 5/13, 5 comma 13, 7 and 5 comma 13, or you can use, what would that be? This would be x equals 0, y equals -5, right? Yeah. No, it would be -5, 1. That's what it would be. So you could have also chosen 0, 7, and then gone down 6 and to the left 5, and that would put you at the point -5, 1. And my math lab would have accepted that also because you're using the slope as a roadmap. And what that means is, if you have a line in slope-intercept form, you don't have to go to all the trouble of finding 2 points. You're given the y-intercept, and then you just have to use the slope as a roadmap to the next point. So you actually don't have to do any calculating at all, which makes it easier if you don't like to calculate. Now we're going to do another, don't worry, so you can kind of catch on to this. Next one. Number 5. No. Yes. Here's the other possibility for slope. Okay, what we have, remember f of x is just y. Y equals -6/5, not really creative, is it? 6/5, -6/5 x minus 5. So we know immediately that the y-intercept is 0, -5. Now, the slope is going to give us a roadmap, but we have to analyze this. This is 6/5 with a negative sign out front. That is not much of a roadmap. Not when you need to decide, am I going to go up or down, or am I going to go left or right? So what you're going to have to do is at least mentally change this. And you can change it in 2 ways. -6/5 is exactly the same thing as -6 over +5 or +6 over -5. Negative divided by positive is negative, and positive divided by negative is negative. So they're entirely equal to each other, but these 2 forms tell you, well, they translate into movement. This says go down 6 units and to the right 5 units. This says go up 6 units and to the left 5 units. From the place you start, and where you start is the y-intercept. So let's do this. I'm going to write that out here. I'm either going to go -6, 5, or that's a -6, or I'm going to go +6, -5. Okay, because this page is kind of covered up. Okay, now I'm going to click, and I'm going to click. Okay, my y-intercept is -5, which has nothing to do with that 5 down there, just so you know. It's a coincidence. I'm going to click on the line, and the first thing I'm going to do is click on -5. Now that's -6. So this would be -5, and I look for agreement in the upper right-hand corner on the yellow banner. It tells me I'm at 0, -5. And it still says that. Okay, good. Now, I can go down 6 and to the right 5, or up 6 and to the left 5, and normally you're going to have a 10 by 10 graph. So if I were to go down 6, I'd be at -11, which would be beyond the endpoints of the graph. So I would have to use up 6 and to the left 5. And that's what I'm going to do just because I feel more comfortable. So I'm going to go up 6 and to the left 5. So 1, 2, 3, 4, 5. 6, yeah, 6, okay. And to the right 5. 1, 2, 3, 4, 5. No. There. Now let me make sure. Well, it's all right. It'll tell me I'm right or wrong. Okay. Edit coordinates. Okay, it's going to let me edit. I wonder if that's a hint. Okay, -5. Now I chose to go up 6 and to the left 5. Now maybe it doesn't like that. Let's see. Oh, okay, it took it. Kind of got nervous there when it said edit coordinates. It's like, hey babe, you got it wrong. But I got it right. It's okay. But look, I'm going to X out of this again because I want you to see on this 20 by 20 grid, look what would have happened if I had gone down 6 and to the right 5. It would have been completely okay. I would have gone down 1, 2, 3, 4, 5, 6, and to the right 5. 1, 2, 3, 4, 5. And see, I would have landed on the line. So I could have gone that way and would have been marked right. I could have gone the way I went and was marked right. And if I had put any other points on there other than this point and this point, or this point and this, wherever it was, over here, I guess, wherever, if I had done that, I would have been marked wrong because slope intercept means slope intercept. Okay, now let's see what the next one is. Look at that standard form. I'm going to have to put this in slope-intercept form to be able to graph it the way that my math lab wants me to graph it. So, number 6. Number 6 starts us off with 3x plus 5y equals 15. Now, if we had been asked for the intercepts, this would be great for the intercepts. However, that's not what we're being asked for. So I have to solve for y. I'm going to subtract 3, wait. Once I see that I have to subtract 3x, my life will be much easier if I put the 15 back here. Now that's a positive 15, so I'm going to put a plus in front of it. Now I'm going to subtract 3x from both sides. Now over here, 3x minus 3x is 0, which leaves me with 0 plus 5y, which is just 5y. Over here, I'm going to have negative 3x plus 15. To get y by itself, I have to divide by 5, and divide by 5. These cancel, leaving me with y equals negative 3/5 times x plus 15 divided by 5 is 3. And now what do I know? I know that my y-intercept is 0, 3, and my slope is negative 3/5, which means it could be negative 3 over positive 5, or it could be positive 3 over negative 5, and I have a choice. I could go down and then right, or I could go up and then left. So let me save that. Okay, and now I'm going to graph it using my roadmap. So click, and it's a straight line. And I'm going to go to the y-intercept 3. Let's see, 1, 2, 3. And then I have to plot the second point. I am going to go down 3 and to the right 5. Down 3 and to the right 5. So I end up with the intercepts anyway. So let's see if I'm right or if I'm moving too fast. No, and it worked. And that makes me happy, of course. And now we're going to go on to some of the more interesting lines, which is the vertical and the horizontal lines. They're really weird. They look weird, don't they? All right, let's look at this first. This is number 7. Y equals 5. When you're doing math, you expect a line to look like 3x plus 5y equals 15. or you expect a line to look like y equals negative 6/5 x minus 5. You don't expect a line to look like y equals 5. But they do look like that. Actually, what this really is, this line is really, okay. This line is really y equals 0 times x plus 5. And so what does that tell us? That tells us that the slope is 0. Can happen. Now, if you want to know for sure how to graph this, if you wanted to use the slope-intercept form, you would put a dot on 5, and then you would not go up or down. You would just go horizontally to any point you like. You get a lot of freedom, too. So I'm going to go over here, and I'm going to do this a more traditional way. Suppose I make an X and a Y chart. The thing is, this tells me that y is 5. So no matter what, in both of these points, y is going to be 5. And indeed, in all the infinite number of points on this line, the only stipulation is that y has to equal 5. X can be anything because you don't see an X there. Or if you're doing it like this, X can be any number because it's going to get multiplied by 0 and just get turned into a 0. So X could be 5 million. 0 times 5 million is 0. X could be negative 2. 0 times negative 2 is 0. It doesn't matter. So if it doesn't matter, go for the easy numbers. How about 3 and 1? They're easy. Now I'm going to graph those two, I'm going to plot those 2 points. Okay, so, and what did I choose? I chose 3, 5, and 1, 5. Okay. I chose 3, 5, and 1, 1, 5. It's a horizontal line. All horizontal lines look like that. They all start with a y equals, and then there's a number. So y equals a number is a horizontal line. Excuse me, I'll be right with you. Y equals a number is a horizontal line, a flat line. Now, what is the slope? Well, it's 0. And I'll show you a way to find that out so you don't have to memorize it. Okay, I'm going to X out of it. I'm not ready to go on. I'm going to show you how to use your 2 points to get a 0 slope. I'm going to let x1, y1 be that 3, 5 point. And x2, y2 be 1/5. Now, slope equals y2 minus y1 over x2 minus x1. And that's going to be, okay, 5 minus 5 over x2 minus x1, that's 1 minus 3. So you're going to have 0 over -2. And if you pull out your trusty calculator and say 0 divided by -2, you'll just get 0. 0 divided by a non-zero number is just 0. So you can calculate the slope, and if you calculate the slope and get a 0, you'll know it's a horizontal line. Or you can just memorize that horizontal lines have a 0 slope. Okay. Now, a trick problem. But this is just this problem. F of x is y. So f of x equals 5 is exactly the same thing as y equals 5. And you'll get exactly the same graph. Five. Zero. Yep. All right, now we get another one, y equals -3. That's a horizontal line through -3 on the y-axis. So we can do these really quickly. Go to y equals -3, which is on the y-axis, and then go to the side any number of points you want, and save it, and check it. What? Note that the value of y is given to draw a, oh, to heck with you. Y equals -3. Oh, darn. Yes. Silly person. Y equals -3. That's negative. Duh. Okay. There you go. And again, the slope is 0. You can actually work that out with a couple of points. Or, it's only giving me 50%? To heck with you. I'm going to go back in and rework the problem later, and I can get 100%. It'll let you do that. All right, now, thank goodness, we are out of the y equals, and we are into the x equal, the other weird line. Now we can find 2 points. Notice that x has to equal -3. And I will try not to forget the negative sign. So I'm going to come up with 2 points, but x has to stay -3. Now, y, the y position can be filled with anything I want. So my philosophy is choose something easy, like how about 2 and 5? Okay, so I'm going to do that. 2 and 5. I'm going to graph it. Graph. Okay, x equals -3, y equals 2. So x is -3, y equals 2. And x equals -3, y equals 5. And that is a vertical line through x equals -3. Let's find the slope. x1, y1, x2, y2. Okay, m, slope, equals y2 minus y1 over x2 minus x1 equals, okay, y2 minus y1, 5 minus 2, over -3 minus -3. Okay, well, that's going to be 5 minus 2 is 3 over, now you've got two negative signs together, so that turns into a plus. -3 plus 3. And if you put that in your calculator, you're going to get 3 over 0. And that is the ultimate thing in mathematics you are not allowed to do. You are never allowed to have a 0 in the denominator. And if you put that in your calculator, you'll get an error message. Always. So that's a good way to help you remember. This is undefined. The reason it's undefined is that if you take some numbers, little bitty fractions or decimals, and let them get closer and closer to 0, that is smaller and smaller and smaller and smaller, you're going to notice that 3 divided by that number gets bigger and bigger and bigger and bigger and bigger. And ultimately, 3 divided by 0 is infinity. And there is no definition for infinity. Nobody really knows what infinity is, except it's really big. So, that slope, the slope of a vertical line, is undefined. And all vertical lines start with an X, don't have a Y. They start with an X equals a number. So X equals a number, any number, is a vertical line, straight up and down. Undefined slope. And this was number 10. And now I have to come over here, and it would be wrong if I tried typing in undefined, because they offer you that answer down here. The slope is not defined. So all you have to do is click on B there and then check your answer. And it agrees. Okay, now here's the last one. Oh no, what are you going to do with yourselves if we get out early? Well, you can hang around and ask questions if you need to on any of the homework. But I'm going to do this. It says graph the following equation and if possible, determine the slope. Well, I'm going to have to solve this. I'm going to have to get all my variables on one side, my numbers on the other, And as it is, notice that all you've got is x's and you haven't got any y's. It means it's going to be a vertical line. But let's do this. Number 11. Okay, so we start out with 10 minus 2x equals 4 plus 3x. Well, I guess I'll move my variables together first. How about plus 2x plus 2x minus 2x, or negative 2x plus 2x is 0. So I'm left with a 10, or 10 plus 0, which is 10, equals 4 plus 5x. Okay, now, I did that right, didn't I? I'm going to have to subtract 4 from both sides now to get the numbers together. And that will leave me 6. So 6 equals, this zeroes out, leaves me 5x. And then I divide by 5 on both sides. Somebody loves the number 6/5. Okay. So we're going to have x equals 6/5, or turned around the other way, x equals 6/5. That's x equals a number, even though it's a fraction. It's x equals a number, and so this is a vertical line. But it looks like I'm going to have to graph it. So let's come up with 2 points. Uh, 6/5 is the x coordinate of both of them, because it says x is 6/5. So x is not going to change in this problem. But I can choose easy numbers for my other for my y coordinates, like 3 and 5, or 2 and 6, or -2 and +2, anything you like. How about -5 and +7? That's already getting hard. But anyway, here we go. I'm going to click. I'm going to click. Okay, look what they've done here. That's -1. This is 1. And you've got decimals, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1. So each inch is divided into 2 parts, which means I need to get the decimal equivalent of 6/5. Well, 6/5 is 1 1/5. I don't feel like dragging out the calculator. So that's going to be 1 plus 0.2, because 1/5 is 0.2, so it's going to be 1.2. So, okay, let me come down here. This is going to be 1.2, comma, -5, and 1.27. We'll go back here. Oh, stop that. Clear. Okay. So I go out to 1.2 positive. Yes. Okay. Is it positive? I don't trust myself now. Okay, x is 1.2. So here's 1. And then we've got 0.1, 0.2. So I'm going to click there. No, not yet, I'm not. Boom. Now, 1.2. Okay, 1.2, and then I'm going to go up down to -5. I can't go down to -5. Okay, I'm going to change it to -2. Down to -2. So let me mark this out and put -2. And I'm definitely not going up to 7, am I? So how about +2 and +2 there? Okay. Okay, so I'll go up to 1.2, +2. I guess I'll make it 1.20. How about that? Okay, I'm going to save that and check the answer. Good job. And the slope is not defined. And we are done for the day. Don't tell anybody. College algebra is always supposed to go over time, not end before the end time, even though I have to admit, we haven't saved a lot of time. Maybe you could run get a Coca-Cola before your next class. Or you could hang out here with questions. I'm going to stop recording, but I'll still be here.